Hello and welcome again. So to start with, we're going to be looking at the content that we're going to be going through for our floors design in this series of videos. To start with, the criteria that we are designing our floors for is typically these four and to some extent five with the acoustic at some situations. So there's strength design, serviceability design, durability design, fire design, and acoustic design to some extent. So to start with strength, it's fairly common. Everybody can understand that slabs and floors are typically designed for strength. So everyone is clear on what is bending, I'm assuming, and everyone is clear on shear, whether it's a one-way shear or a punching shear. Serviceability design is more to do with the function of the building, and it's to do with limiting the deflection of the floors, the cracking of the concrete floors, and the vibration of the floor as well. So it's comfortable for the people who are using the building, and it doesn't stop the functionality of the building. Durability design is more to do with protecting the steel reinforcement in the concrete from actually corroding in the long term, especially due to being near to the sea or being in contact with the ground or just the carbonation of concrete pretty much over time. Fire design is to do with maintaining the integrity and the structural strength of the building during a fire event. So usually we design buildings for a certain times because no building can withstand fire forever, but the building needs to stand fire for a sufficient period of time until the firemen can arrive on site and rescue the people before the building collapses or before the fire is being put out eventually. Acoustics is to do with the acoustic performance between the floors, so you and the neighbor below and the neighbor above doesn't hear a lot of noises in your building, especially if there are things like car park below your building, or if there is machinery like a water chiller plant or something. So there's some certain acoustic requirements as well that sometimes is required to be incorporated into the floor's design. It's not much of a structural engineering task, but it's a criteria that we always take into account when we design our floors. Now that we understand the 5 floor design criteria that we're going to be going through in this series of design videos, now let's look at the systems of the floors that there is actually. In my opinion, there is probably only 2 types of systems that you'll ever come across in your design of a floor. And these 2 systems are either a beam and slab system or a flat slab system. The beam and slab is the most efficient system you can probably use, and it has a lot of different forms of usage. So the traditional one where you have a beam spanning between columns and the slab spans between the beams, and this can be a concrete system or it can also be a steel system where you have a steel beam, on top of it is a metal deck, and on top of it is a concrete topping slab that spans between the steel beams. It can be in the form of a lot of secondary beams as well. Again, that can be concrete and or steel beams, or it can be a waffle slab in some cases, or a ribbed slab where you have a lot of small joists that reduce the span a lot for the slab. And these joists basically span the load back into the main beams, which is often called girder beams or primary beams. This video is part of Concrete Floors Design course that's available online on Udemy. If you'd like to watch the full course, you can access it via a discounted link from the description of the video. When you click on it, you'll be able to purchase the course for a heavily discounted price than the original price, and you'll get access to about 4 hours of lectures on floor design covering all areas from analysis to flexural, including bending and shear, as well as deflections and vibrations, minimum requirements, durability, and fire design. Now the other type of system, which is a flat slab system, is where you don't have any beams and it's just a plate, basically a slab that spans between the columns directly. And this type of system typically has issues with punching shear, that the slabs just fail locally around the column because it's too thin. So you might often find there's drop panels below the slab around the column areas. Now it doesn't make much sense to actually go for a flat system in terms of using material wise compared to a simple beam and slab system. But it does make sense in terms of constructability and in terms of end use of the building. So in some countries, labor is actually quite expensive, and forming all the beams in the building can actually end up being more costly than just pouring a thicker slab throughout that you don't need so much time to form on site. And the other reason is, if the concrete is exposed, nobody really wants to look at the ugly system of beams and slabs on top of them. It doesn't feel nice. But if it's just a flat slab, it's actually not too bad to look at it. And in some cases, it can be exposed concrete as it is. It can be painted black, and that's quite modern decoration and interior design these days as well. And it saves on the cost of having to put up ceilings and stuff like that. So it does has its merits and its benefits as well. And in the next few videos, we'll explore the design of these two systems, slabs and beams, as well as flat slabs, to these 5 design criteria. See you in the next video.